Despite the beauty and allure of blue holes, they are some of the most dangerous waters to dive. Nitrogen narcosis begins to set in at depths below 20 meters 70 feet and causes disorientation and changes in consciousness. Divers experiencing nitrogen narcosis may become too confused to swim back into shallower waters, and some never make it back to the surface. Water clarity and light both decrease significantly with depth, adding to the disorientation divers experience. Divers must also remain aware of the animals they may encounter in these holes. Shark species, including bull sharks, reef sharks, and hammerhead sharks, have been seen making use of blue holes and occasionally attack humans. A blue hole is a large marine cavern or sinkhole, which is open to the surface and has developed in a bank or island composed of a carbonate bedrock, limestone, or coral reef. Blue holes typically contain tidally influenced water of fresh, marine, or mixed chemistry. They extend below sea level for most of their depth and may provide access to submerged cave passages. Well-known examples are the Blue Hole of Dahab in the Red Sea, Dragon Hole in the South China Sea, and, in the Caribbean, the Great Blue Hole and Dean's Blue Hole. Blue holes are distinguished from cenotes in that the latter are inland voids usually containing fresh groundwater rather than seawater. Blue holes are roughly circular, steep-walled depressions, and so named for the dramatic contrast between the dark blue, deep waters of their depths and the lighter blue of the shallows around them. Their water circulation is poor, and they are commonly anoxic below a certain depth. This environment is unfavorable for most sea life, but nonetheless can support large numbers of bacteria. The deep blue color is caused by the high transparency of water and bright white carbonate sand. Blue light is the most enduring part of the spectrum. Other parts of the spectrum, red, yellow, and finally green, are absorbed during their path through water, but blue light manages to reach the white sand and return upon reflection. The deepest blue hole in the world is the Tamya Blue Hole in Ketchimal Bay, which was found to have a depth of more than 420 meters in 2024. The second deepest is the Dragon Hole, or Longdong, in the South China Sea at 300.89 meters deep. While the third deepest blue hole in the world is Dean's Blue Hole at 202 meters, located in a bay west of Clarence Town on Long Island, Bahamas. Other blue holes are about half that depth at around 100120 meters. The diameter of the top entrance ranges typically from 25-35 meters Dean's Blue Hole to 300 meters Great Blue Hole in Belize. The overall largest blue hole, taking into account depth and width, is located 100 kilometers from the coast of Belize. The Great Blue Hole is a massive 300 meters wide and 125 meters deep. Blue holes formed during past ice ages when the sea level was 120 meters lower than at present. During these times, the formations were exposed to the same erosion from rain and chemical weathering that is common to all limestone-rich terrains. The process ended once the sea level rose at the end of the Ice Age. Most blue holes contain both freshwater and salt water. The halicline is the boundary surface between the freshwater and the salt water in these blue holes, where a corrosive reaction takes place that eats away at the rock. Over time, this can create side passages, or horizontal arms, that extend from the vertical cave. These side passages can be quite long, over 600 meters in the case of the Sawmill Sink in the Bahamas. Blue holes are formed through karst processes and require a specific type of topography. Rocks such as limestone, gypsum, and marble are soluble, and dissolution creates passages and cave systems underground. This process, in combination with doe-line formation, permits blue holes to be formed. Doe-line formations were once closed depressions formed by solution of superficial rock where subsidence collapse into an underground void. Most blue holes are formed through these processes, although some do not show any sign of passages or cave systems, as would be normally expected from karst and doline processes. This suggests that some blue holes may be caused by other processes such as vertical reef development. Some blue holes do not experience karst or doline processes during their formation. They form through bedrock dissolution and collapse, usually influenced by tidal forcing, carbonate dissolution, sea level fluctuations, or the presence of eogenetic carbonates. Many different fossils have been discovered that indicate the type of life forms that existed in blue holes. Other life forms such as marine life and marine fossils have also been noticed. Crocodile and tortoise fossils, for instance, have been found in blue holes. Important types of bacterial colonies have also been found in blue holes. Due to the conditions of a blue hole, they are forced to live off sulfur compounds like hydrogen sulfide, which are toxic to most organisms. These special bacteria have produced many insights into the chemistry and biology of microbial life. Blue holes have a great diversity of microbes. They create biogeochemical pathways, creating a unique and diverse environment within the blue holes. In the surface layer, oxygen, DOC, POC, and chlorophyll need to be in low levels in order for cyanobacteria to respire as depth increases. Many branches and sub-branches of microbes create specific niches based on the chemistry and nutrient availability of that depth. The chemistry of blue holes vary greatly depending on how they were formed. All blue holes have a layer of fresh water at the surface and more saline water as the depth increases. Many have pycnoclines and haloclines that show these zones, similar to the ocean around it. Many blue holes are great sediment traps and can preserve climate and fossil records dating back to the last glacial maximum. Exploring blue holes requires a level of competence and equipment appropriate to the depth and overhead penetration. In 2009, a team of scientists set out to study 7 of these blue holes in the Bahamas through over 150 dives. The scientists, led by Keith Tinker, investigated bacteria able to live in anoxic environments. This allowed them to make connections to fields such as astrobiology, where organisms thrive without oxygen or sunlight. In 2018, another group of scientists set out to explore the Great Blue Hole of Belize using 2 submarines of the latest technology. One of the major scientific contributions to result from this expedition was the first 3-dimensional map of its interior. The researchers captured features such as stalactites, the hydrogen sulfide layer, and other details that cannot usually be seen by the naked human eye. As part of a 3-year study, a group of scientists set out in May and September 2019 to explore a blue hole nicknamed the Amberjack Hole, located 30 miles off the coast of Sarasota, Florida. Individuals from Mote Marine Laboratory, Florida Atlantic University, Harbor Branch, Georgia Institute of Technology, the United States Geological Survey, and the NOAA Office of Ocean Exploration participated in the expedition. The expedition gathered information about life around and within the hole, seawater composition, and the hole's bottom sediments. A follow-up expedition is planned in August 2020 to a deeper blue hole named the Green Banana off the coast of Florida. In contrast to the various successful expeditions completed, many explorers have perished in their attempts to reach the bottom of a blue hole. The Red Sea Blue Hole located in Egypt is nicknamed the Divers' Cemetery because at least 40 divers have died there.